Hello. Today we're going to be working on the CodeCheck Python exercises for complex loops assignment. I'm going to go into full screen. Trace through the following code. Press start to begin. Please enter the new value of n. For n in range 2, 4. So starting at 2 and including it, going up to 4 but not including it is what that reads. So for n in range 2, we're going to start at n2. Correct. P equals 1 inside the loop, so P is 1. For I in range 1, 4. So I is starting at 1 and including it, and going up to 4 but not including it. So I is 1. Now P is P times n. P is 1 and n is 2, so 1 times 2 is 2 for the new value of P. Print %2d, so this is a formatted 2-digit decimal number, I think, is what this format specifier means. It's going to print this in a certain format, so % is kicking off the format specifier, and then it's going to be 2d, meaning I think 2 digits, or what is %2d? Let's just Google it just to double check because it's important. Takes up at least 2 columns. So this is about C, which is where this comes from, but it's used in Python. So I'm going to search Python format specifier. See an example, %. Let's ask the Google search a follow-up question, %2d. Right aligned with a minimum field width of 2. So space 5, 42, minimum. So only when it is less than 2 digits, it's going to leave space for it, is what it seems like. In modern, you should use F strings instead of the old %. Interesting. So it's %2d, %p. Let's just ask AI about this whole line while we're at it. This code prints the integer variable p right aligned with a minimum width of 2 and suppresses the default new line at the end. Mod p is what that looks like to me, passes the p variable into the placeholder. P equals 7, %2d, %p, n equals this, print abc out, 7 abc. Okay, so it's just saying print this with double width and pass in p. Yeah, I don't use this format specifier in Python a lot because there are different ways to print strings, and this is not my favorite, but good to dig into that a little bit. For I in range 1, 4, now we're at the second value of I, so this will be 2, I believe. P is P times n. P was 2. N was still 2. So 4. Print P. For I in range 1, 4. I'm going to go up to 3. Next line to be executed. I in range 1, 4. I assume this is after we just did the I is equal to 3. So we're still going to go into the loop this time. They're trying to get at, then when are we going to stop, I think. So p is p times n. P is 4, n is 2, p times n is 8. Wait, did I just get that wrong? Oh no, 9 correct 0. I'm only halfway through. Wow, this is long. For n in range 2 to 4, so next we're going to go to 3 for n. P is 1. For I in range 1 to 4, we're starting back at 1 all over again. So we're not going, we notice we stop at 3 and not 4 because this one is exclusive of 4, even though the start is inclusive of 1. So now we're back at 1. P equals p times n. N is 3, p is 1, product is 3. We're going now from 1 to 2. Next we're doing p times n. 3 times 3 is 9. New value of I is 3. Next line to be executed is here. Again, not a trick. P is 9, n is 3, product is 27. And finally we're done. 380 seconds. Wow, I'm slow, I guess. That's okay. Rearrange the following lines of code so they print the following shape. Not all lines are useful. So we're going to go 3 rows of 1, 2, 3, 4, 5 columns. So we're going to be printing 1, 2, 3 rows, and then within each row we're going to print 1, 2, 3, 4, 5 columns. So we should do the rows first because we can go left to right, then create a new line, then go left to right, then create a new line, then go left to right. So we want to start with the rows. That's important. It wouldn't work the other way around. So we're going to go for 0, 1, 2, which would be I in range 0, 3 to do the rows. Click start. For 0 to 3, then we're going to do within each row, we're going to do each column from 0 to 5, 0, 1, 2, 3, 4. 5 is exclusive, meaning it's not included. Then for j in range 0, 5, we will print brackets end equals empty quote means we're not going to do a new line, which means we don't enter to a new row when we're trying to do new columns. Then we could do yeah, this one's not needed. Then print with nothing is just going to print only the new line and return to the new line so that we can start our new row. And then that should be everything. And it's correct. Complete the following program to make a table of integers from 0 to n inclusive and their square roots. The table should be formatted like this one and display the square roots to the same number of decimal places. Okay. So we're going to have to do some formatted input here, but we don't have to use the format they used earlier. We can use an F string or concatenate it manually or whatever we want to do. So they already printed the top of the table. We just have to print from 0 to n inclusive. Yes, so for I in range, we could choose anything, but I'm choosing I. It's a common one to choose. For I in range n inclusive, so we want to do inclusive, which means we need to do n plus 1 to actually include that, because normally range is exclusive. And we'll print, I think it looks like there's a space here. Space, and then two spaces, it looks like. or maybe it's a double width, so it's going to be double width on this number, meaning it'll be like a %2d we saw earlier. So I would probably use an f string like that looks like this. So f before the string says I'm going to put formatted stuff in here, and I'll probably have to look up Python f string. We could use W3 Schools. It's a decent source. Price, okay, but yeah, we need to format in a certain way. So 0.2f would be like 2 double width decimal, or we need like double width column and a certain width of decimal. So maybe we need like 2 point something, and that something is going to be the width. Looks like we're freezing. Okay. The width is 1, 2, 3, 4, 5, 6 on that. So I think we want something like the format part of this is going to be 2 double width for before the decimal, I think, and then 2.6 D. I don't know if we need the D. F. 2.6 F. And this will be the number. We need 1 space before that, and then there were just the double width of the number, I think. And then we have 1 space. We have the pipe. We have 1 space before the pipe, and then we have the N, which it looks like is 1, 2. It's either triple width or it's a space and then a double width. So maybe space N. Nope, I, not N. And maybe I colon 2.6. Nope, not 2.6, just 2F, 2D. I'm not sure. See more modifiers. So we have decimal format, maybe it's just 2.0, 2.0f. Could that be? And here we're going to do sqrt, I think is built in. Or no, math square root. Yeah, so it's imported. And square root of I. This I don't think is going to be right, but we're going to run it. Don't need the dot dot dot. Okay, we're not too bad. Looks like there's no space after this. Hey, maybe right? Yes, that looks right. So how did I figure that out? I just know a little bit about these format specifiers. It's okay if you have to Google what those are, but pretty much this curly brace is not printing. The curly brace itself is not printing. It's just saying, I'm going to start saying something that's a variable that I want you to turn into a string. So this f string was what we put this into, and we're specifying literal characters like the space, the pipe, the space, and then we're specifying things we want to be turned into strings from variables. So we're saying take I and turn it into a double width with 0 decimal places floating point number. So that's just an integer format, this double width. And then double width is important because it means it puts the space before these single digits so that the double digits are lined up in the same way. And then square root of I is saying do 2 before the decimal point and 6 after the decimal point. So 2 here, double width, and then 6 after. Complete the following program that displays 4 hashes, 3 hashes, 2 hashes, and 1 hash, filling in the correct conditions of the 2 while loops. Alright. Start with j equals 4, probably the number of hashes, while j is greater than 0, I'm guessing. Well, there are still some number of hashes to display. Then k equals 1, while, what is k for? 1, I guess we have one of these is going to, j or k, one of them is going to be the number of rows, and one of them is going to be the number of columns. So we probably should start with rows. So number of rows is going to be j. Well, the number of rows is greater than 0, then k equals 1. While, why would we be doing this? Why would we start at 1 and not start at 4 hashes? Because we have 4. Okay, we're adding 1 while k, okay, so while k is less than, we need to do 1 first, 2, 3, 4. So we could do less than or equal to 4, or we could do less than 5. So I'll do less, since it's conveying the number 4, I'm going to do less than or equal to 4. While k is less than or equal to 4. Print hash with no new line character. Then increase k by 1. Oh, is that the entire, that's the entire thing? I have to implement. Whoops, and then oh, I'm allowed to do more here. And then okay, well, k equals 1. So now we're doing 4 for each of the 4 rows. Then print while k is less than, while k is less than the row that we're on. So maybe while k is less than j, because we're going to be starting at row 4, we want to do 4, and then on row 3, that doesn't seem right either. I guess that's right. Well, k is less than j, so while the row number, while the column number is less than the row number, for row j equals 4. So we're going 4 for the rows. 4, 3, 2, 1. And so we want to print the k's. The number of hashes to print is going to be 4, 3, 2, 1, depending on which iteration of the loop we're on. Clever. Complete this program that reads an integer n and prints the following diamond pattern with 2 times n minus 1 asterisks at its widest point. This is the pattern when n is 3. 2 times n minus 1. This is the pattern when n, this is a mind bender. For left stars, so we're getting an n. 2 times n minus 1. So 2, when n is 3, 2 times n is 6, minus 1 is 5. So we need to print 5 stars at the widest point. We need to learn how to read this code and understand what's going on, and then draw the bottom half of the triangle. top and middle of the triangle. So for left stars in range n, for column in range 2 times n minus 1, so the full width is 2 times n minus 1, which is 5 in this example. First star is n minus 1 minus left stars. Left stars is starting at 0. First, no left stars. Does that make sense? Yeah, no stars to the left. One in the center, none to the left, none to the right. Last star equals n minus 1 minus left stars. Okay, so the column position, n is 1, 2, 3, 4, 5 stars, n stars, n minus 1, the fourth position, meaning the last one, n minus 1 plus left stars. Okay, so when should the last star be? N minus 1 plus left stars. We're starting at 0 left stars, so just n minus 1. If column is less than first star or column is greater than last star, print dash. Well, even if this logic is a little bit confusing, we can basically just reverse it. So one thing we could try would just be taking this, pasting it, and just saying for left stars in reversed range n. But we can't do that because we're double printing this here. So we should probably do it from scratch, but really we just have to make sure left stars in reversed range n, except if left stars is equal to n minus 1, then we don't want to execute this, so we'll just break. Or left stars is now we want to only not print the when left stars for column. So reversed range and left stars is 0 stars to the left, then 1 star to the left. So this is 0 stars to the left, 1 star to the left, 2 stars to the left, and n was 3. So yeah, so if n stars to the left is n minus 1, then we need to pass, meaning or continue, meaning we swing around the loop, we skip all of this stuff, but then we continue doing the loop. Break would just end the loop early. And that is correct. But they probably wanted us to write this from scratch. So I wonder how we should have done this. I mean, it's really just the same thing. We're trying to go from the number of stars being none up to the number of stars being n minus 1. Do we want to go from the number of stars being n minus 2 to 0? So I guess another way to head this off would have been, instead of this, could have said for left stars in range starting at n minus 2, ending at 0, and or 0 going past 0, so exclusive of 0. Instead of 0, we need to go to -1 by steps. There's a third argument to by steps of -1. So I think this will work. It says go from starting at n minus 2, going until the exclusive stopping condition of -1. So when you get up to 0 or down to 0, going by steps of -1. So decreasing from n minus 2 to n minus 3 to n minus 4, unless you hit or go past 0, maybe. Seems like it still worked. So I don't think they really wanted us to rewrite this entire loop. I think they just wanted us to understand which aspect was controlling this and how to know that this is the first half and we're working on the bottom half of this. And to understand that we're starting at n minus 1, meaning so n minus 1, n would be this like 3 here, so 2 stars minus the number of left stars that we're working on. So if we have 2 stars minus the number of stars we're trying to put, which is 2, then the first star is at 0 and the last star is at two plus 2 is 4. That doesn't make sense. 0, 1, 2, 3, 4. Anyway, interesting logic here. For column in range 2n minus 1, the widest part, is going to be 5 stars. 1, 2, 3, 4, 5 rows as well. If we're on something less than the first star, we're going to be printing dash if our column is less than the first star or if it's greater than the last star. So we're talking about the position of the stars. The first star would be this one or this one. The first star would be this one, or this one would be the last, first and last. And then the reason that that works in the beginning, we're starting in range, column is 0, and we're talking about printing column 0, and we're wanting to put a dash. The first star, when left stars is or let's look at this one. First star, when left stars is 0, would be n3 minus 1 is 2 minus left stars of 0 is 2. So the first star is at 0, 1, 2. Okay, makes sense. Last star is at n minus 1, so 3 minus 1 is 2, plus left stars, 0 left stars is 2. So last star is also at 2. So that makes sense how this is going to work down here. Then in the next time we have left stars is equal to 1. So symmetry, right stars is going to be the same. First star is going to be n minus 1 minus left stars. Okay, so n minus 1 being the n minus 1 being the center position. That's the conclusion here. 2n minus 1 is you're having a symmetrical thing about this middle point. And so this middle point is your n 0, 1, 2, n minus 1. So for 3, your third position is your 0, 1, 2 index, which is n3 minus 1 is 2. Hopefully that's making sense. If not, take a little bit more time to look at this code, because even though we were able to solve the problem, it's important to be able to follow the logic of why did we approach it like this? Why this n minus 1 minus left stars? Trying to figure out what's the reasoning for that, and not just working with the code and assuming that it's correct. I think that is the end of this assignment.